Class? DPS is 9 and 11. Newtown? 8, 9? Only 8, 9. Okay, great. So we were planning to start by 10, but now it's already 10:45. Okay, so we have already speakers waiting for you, and we have requested them to cover both the talks because we were planning to have an extended talk since it got little late. So they will cover both the talks in a format that is understandable to you, in a manner that is not very difficult, that is interesting, and you can understand what this all about, this Galaxy Zoo and the next talk. So both the talks are squeezed in a 45-minute segment, and within these talks, we will have quiz session. Now the quiz will be conducted by speakers itself and their group, where they will be asking questions based on the deliberation that they are making, not on the fact that is given in your syllabus. Correct? So if you want to win some prize and take something back at home, so you need to listen. And if you feel sleepy, then you won't win any prize. Choice is yours. So I won't take any more time, and we'll start the talk because we are running out of time. And Newtown teachers, if you want to visit this exhibition after this, okay, please meet us so that we will guide you accordingly. I had already talked with the teachers of DPS that what we are planning to do after this. Okay. So both the lectures will end, and within these two lectures there will be a quiz session. After this lecture, DPS will be going to Science City in the exhibition area. Okay, and after that what will happen in the exhibition area and where you will spend more time, that will be delivered to you by your teachers. Regarding Newtown, you can talk to me directly. We will settle up that what is your future plan after this lecture. Is this clear, Newtown teachers? Great. So we are starting the talk. Have a good session. I can say that you came on a date where the most interesting talk is there. So listen to it, win some prize. Yes, please.
Good morning. So before we start, let me say a few words about the Vigyan Samagam. So Vigyan Samagam is a multi-city mega exhibition organized by the Department of Science and Technology and Department of Atomic Energy, the Government of India. And this is first of its kind. And it is happening only in 4 big cities, metro cities. First it was held in Mumbai, then it took place in Bangalore, and the third edition, which is taking place now in Kolkata, and the last edition will take place in New Delhi. So it's a very unique and very opportunity. So the idea was to actually inform students about the experiments that the Indian scientists are currently doing, and what are the big questions they are trying to find answer to. So as a part of this, we have organized the talks at a level that you will be able to understand at least some part of it, and that was the goal. So we have been organizing talks since Tuesday as a part of SKA week. SKA is the Square Kilometer Array. It is a project, international project, that is, the aim of this project is to build world's most powerful radio telescope. World's most powerful radio telescope. 20 countries are taking part in that, and India is one of them. So it's a very good opportunity for the Indian scientists and also for the coming generations. I'm also involved in that, and so today our speakers are Professor Soumyadip Samui, Professor Soumyadip Samui, and Professor Soumyadip Samui is a very renowned astrophysicist and currently assistant professor at the Department of Physics, Presidency University. And he will talk about one science goal that the SKA, the Square Kilometer Array, is going to pursue. And the next talk is about early universe, the dawn of our universe, when universe actually became visible. So, and that talk will be given by Mr. Avinash Kumar Shah from IIT Kharagpur. So thank you, and I will request Professor Soumyadip Samui to start delivering his talk. Thank you.
Thank you, Kanan, for such a nice introduction. So as Kanan, I should introduce him as well. He is Professor Kanan Dotto. He is also an assistant professor in Presidency University, working in the astrophysics area and directly related to the square kilometer array that is going to be built in Australia and South Africa jointly. So it's a big mega project, and as you understand that this is just starting to be the beginning of such kind of facilities. It will be start operating, let's say around 2025. That the time when you will be starting, you are likely to starting your career as a researcher. So that will be a very good opportunity for you to work on such kind of instrument. Well, now just what kind of science you can do in such kind of instrument, that is the major goal of these lectures. Well, one of them is to study galaxies, and that part I am going to describe you. As the title of my talk says, it's the journey to the galaxy zoo. From the morning you are making lots of journeys to come to this place. I guess you have wake up in the morning and then went to your school. From school you have come to the science city, so it was a long journey. And you will also be little bit more patient. You will going to get the journey along with me for, let's say, next 45 minutes to understand what galaxies are, what they are made of, and things like that. Okay? So, anytime if you have any question, just interrupt me. Say that, sir, I have a question. Okay? And as you have said that, I will be asking questions to you. If you can answer it, you will get prize. Well, so let's start the journey. So the journey is going to follow like this. So first, I am going to describe what are the galaxies. Then I will describe different kinds of galaxies, what are their shape, size, and what they are doing. Then I will say something called high redshift galaxies. I will come to that later, what are the high redshift galaxy mean. And finally, I will describe what are the things that square kilometer array is going to learn about these galaxies. Okay? So, what are galaxies? Well, galaxy, I don't know what are things. So, let's see what is it. Can anyone answer what it is? Great. Sun. Okay? Quiz question. There is something out here. Anyone? Anyone? Raise your hand. Raise your hand. Yes? No? Yes, you? No, that's a good guess. Student. Yes, yes.
Sun's blind spot.
No, it's the same thing as sunspot. Yes? Yes, what spaceship? Sorry? Yes, that's the ISS, International Space Telescope. Give me the prize. Okay? So, the International Space Telescope, this photograph was taken from the Earth, and International Space Telescope was passing through the Sun. At that particular moment, the photograph was taken. Okay? All right. So, this is the sun. But I always like to say it's a twinkle, twinkle, little star. Correct or not? It's a star. It's the nearest star we know. Correct? It's the nearest star that we know. And I also say it's a little star. Are you agree with that or not? It's a little star? Well, let me see. The mass is 2 times 10 to the power 30 kilogram, which means after 2 you have 33 number of zeros, and that kilogram is the mass of the sun. It's almost 3 lakhs times that of the earth. Is it a little star? What do you think? The radius, it's about 7 lakh kilometers. It's also 100 times more than the earth. Is it a little star? Yes, it is a little star because the star mass ranges from 1/10 of the sun mass to the 100 times that of the solar mass. So the massive star which you can see in the night sky, they can have masses starting from 1/10 of a solar mass to hundreds of solar mass. So in that sense, it's really a little tiny star compared to other stars. Okay? Then the sun consists of what we know is the solar system. What it is consist of? Definitely sun, we the earth. So all the planets, comets, the moons, I said moons, our moon and the moons of all the planets, asteroids, these consist of the solar system. Okay? And all the motion of this planet, asteroids, moons, they are governed by only one law, that's the laws of gravity. Okay? So who discovered the laws of gravity? Newton. Someone said Einstein. Actually, the modification was done by Einstein, right? Okay? The first law was given by Newton, that's G m1 m2 by r square. That's the universal law. And all the motion of the celestial object, they are governed by that law. Okay? And also think about the situation. The earth is rotating around the sun. It's going to rotate and rotate and rotate and rotate. It's never going to leave the solar system. This is known as bound system. The earth is bound to the solar system or to the sun. So such system is called as bound system. They are never going to take apart from each other. Okay? So just a pictorial description of the solar system. Okay? All right. Which is the biggest planet in the solar system? Jupiter. Next one? Saturn. Great. And also, this bigger planet, they have their own moons. Who first observed the moons of Jupiter? Galileo. Great. All right. So, we know the solar system. And if you think about it, this is the solar system if someone is going to look it from outside the solar system. Then he can see all of them, well, that's the system. Each planet, they are revolving around the sun. Each moons, they are revolving around the planet. Such thing they are going to see. Okay. Then this is a simple night sky. What do you see in the night sky? Stars. We don't see stars. In Calcutta, what do you see? Only maybe the moon and few bright stars. We never see this kind of stars. This is a photograph taken from some place where there is less amount of light pollution. From there you can see lots of stars. If you can go even in a darker place, you will see not only star, something like this kind of patch. What is it? The Milky Way. Okay? It's the Milky Way. It's our own galaxy. I don't know what is galaxy yet, but we call it, this is our galaxy, the Milky Way galaxy. This photograph was taken from the Atacama Desert in Chile. And it's, sorry. So you see this patch, it's from north to south. And if you look through telescope, you will find it consists of lots of stars, nothing else. The lots of stars, whatever is there, it's looking like a patch in the sky. Okay? So now again, coming back to the question, if I can go outside of our galaxy, how does it going to look like? Anyone? Hands. Yes? Yes, it's going to look like spiral shape. One prize for him. So this one is not the picture of our galaxy. It's picture of here, Kanun. Here. So it's a galaxy named NGC 3370. If we can go outside of our galaxy and take photograph of our own galaxy, it's going to look like this. So it has a spiral kind of shape. It's kind of flattened like a disc. It has a center which has a lot more star compared to the outside, and it has spiral arms. Okay? So this is an artist impression of how our galaxy is likely to be. So in our galaxy, this is the center of our galaxy. It has even a bar kind of structure. There is a bar magnet, you have seen such kind of structure. When I say structure, means the stars are arranged like that. So all the lights from here is coming from stars. And I cannot separate them individually. So I will see a glow of light. And the glow of light will have a bar kind of structure here. You will have two main spiral arms. And our sun is somewhere here, not at the center. Somewhere here, from the center, it has a distance about 8 kiloparsec. Well, anyone know what is a parsec unit? 3.26 light year. Give him a prize. Okay? So, it's just some kind of unit astronomers use. As he said, 3.26 light years. So, which means around 24,000 light years away from the center is our sun. Okay? And is this thing static? No, not at all static. It's like you must have seen pictures of typhoons, the satellite image of typhoon that rotates. Exactly similarly, this guy is going to rotate like this. So sun also, along with all the stars in the galaxy, rotates like this. The center is the center of our galaxy. Well, few more information about our galaxy. So I said it's a barred spiral galaxy. So how it look like? It has a bar kind of structure in the center and it has a spiral disc shape. Okay? It consists of 10 to the power 11 number of stars. 1, then 11 zeros. Okay? Million is 10 to the power 6. Billion is 10 to the power 9. Okay? It has the radius is about 1 lakh light years. And the thickness is very small. So it's a disc kind of shape. Thickness is only 2000 light years. Its age is almost equal to the age of the universe. Right? The mass is 10 to the power 12 times the mass of the sun. 10 to the, but there is something going on. Say 10 to the power 11 star, if you have all stars, how can it be mass is not 10 to the power 11 times mass of the sun? One answer could be that there is more number of massive stars, more massive than the sun. That's not the correct, because we have seen that number of stars as the mass increases is less and less and less. So if you just add the star mass, it's not going to have this 10 to the power 12 solar mass number. Then there must be some other things. What are the other things? It has gas like hydrogen, helium. It has some amount of other elements which astronomers called as metals. Any other element other than hydrogen, helium, say lithium, carbon, oxygen, nitrogen, whatever you can think of. And it has dust, and there is something called dark matter. What does dark matter is? In a simple way, there is something we know it exists, but we don't know what it is. We can feel its existence through the motion of the stars. Nothing else is known to it. Sorry. And you have neutral hydrogen. Neutral means the proton and electron are together. This neutral hydrogen can emit a radiation that is having a wavelength of 21 centimeter. The square kilometer array is going to observe that radiation and infer what is the content of neutral hydrogen in our galaxy, in other galaxies, in the entire universe. Okay? All right. Again, why do you need to choose a different kind of instrument to look at it other than optical? So whatever image you see, that's the optical image, means looking through the optical telescopes. But if you look at in any other telescope means, let's say X-ray, that means we are we are making image with the X-ray telescope, like the X-ray you can have in your any hospitals or wherever. So different wavelength is going to give me different kind of information. Like X-ray image is going to give me information about bones. That's normal photograph is not going to give me that information. Okay? So different wavelength, our Milky Way looks like differently. So that's why we need to have telescopes in different kinds. Like one of them is the SKA, that is the radio telescope. You can have X-ray telescope, you can have ultraviolet telescope, you can have gamma ray telescope, all sorts of telescopes. Okay? So this is our galaxy. Now I can formally define what do you mean by a galaxy in general. Okay? So a galaxy consists of stars. How many stars? It's not well defined, something like 10 to the power 4 to 10 to the power 12 number of stars. Our galaxy has how many stars? 10 to the power 11. So I have galaxies which are 10 times bigger than this. I have galaxy pretty smaller compared to this. They are, as I mentioned, gravitationally bound object, which means they are interacting with each other gravitationally, and the stars are rotating around a common center with the laws of gravity. Okay? And as I mentioned, there are other things like gas, dust, dark matter, things which I have already discussed. Okay? All right. Are we alone in the universe? See, there is only one galaxy? No, not at all. So these two are the nearest galaxy to us. These are known as this is the large Magellanic Cloud, and this is the small Magellanic Clouds. You cannot see them from here, Kolkata. If you want to see them, you have to go to the southern hemisphere. Okay? They are very small galaxies, that was the term as dwarf galaxies, and they don't have any particular shape. So that's why it's called irregular galaxies. Question. Apart from these two, these are also rotating around our own galaxy, so it is called a satellite galaxy to our galaxy. What is the closest galaxy? Great. I can't give you the prize. Okay, give him the prize, because I was waiting for the hands. Give him the prize. So yes, the Andromeda galaxy. It's also look like similar to our galaxy, but it's a much bigger galaxy. Much bigger. It has 10 to the power 12 number of stars. Distance from our galaxy is around 2.5 million light years. Okay? You can probably see this if you go to a very remote place where you don't have lights and you see towards the Cassiopeia constellation, you will be able to see a fuzzy kind of thing. That is the Andromeda galaxy. You can see it in your eyes. Okay? All right. This is kind of the galaxy you I was talking about. So you have all kind of shapes, all kind of size of galaxies. So each of them, whatever is photographed here, is a galaxy. See, it's a spiral kind of galaxy. It's kind of plane-shaped galaxy. I don't know these galaxies, how they look like. This is a ring kind of galaxy. All different shapes and sizes of galaxies are there. But problem is, if you want to do any kind of science, you need to have some kind of classification. So that's what we also try to make, some kind of classification law. This was first made by Edwin Hubble. Is known as tuning fork diagram because of the shape of it. So you have seen tuning fork. This kind of, that's called a tuning fork diagram. What it is? So it says there are galaxies like completely spherical kind of shape, that is known as E0 galaxy. Then it becomes kind of elliptical and kind of getting flattened and flattened. So this way these are elliptical galaxies with ellipticity is increasing from here to here. You have 7 such classification, right? Then you have the spiral galaxies like our galaxy. They are also classified in 2 branches, the spiral galaxy. One having bars like our galaxy, one that they don't have any bars. And depending on how the spiral arms are tightly bound or widened, they have been also classified as SA, SB, SC or SBA, spiral bar A, spiral bar B, spiral bar C, depending on how the branches, the spiral arms are spread over. Okay? So what are elliptical galaxies? Shape is elliptical. All the classifications are here made how they are going to look like. Okay? Spiral, the ellipticals, they have the stars are rotating around the center of them. They have very low amount of star formation. They have very little amount of gas, and their stars, since there is no star formation happening, their stars are more older and they look redder. Okay? So this is an example of such galaxies. This is called as M89. M is for Messier object 89. It is a distance of 50 million light years from us. Well, yeah, as a photograph it doesn't look like very interesting. It's true. The interesting things are these kind of galaxies. These are spiral galaxies. So they have spiral structure. They might have bar at the center. They are flattened and they have ongoing star formation. New stars are forming there. Okay? So that's why they look like a bluer. The bluer galaxies, they are spiral galaxies. This is again photograph of M101 a galaxy which is at a distance of 21 million light years from us. Okay? And why they are flattened? Because of something known as angular momentum. That's why they are flattened to a disk. Okay? This is an image of bar galaxy. So you see bar here and it has the spiral arms. This is NGC 1365. This is one of the biggest galaxies known to us. It has a radius of 2 lakhs light years. It's one of the biggest galaxies known to us. Okay? Then we have this is kind of lens shaped. These are known as lenticular galaxies. Okay? Sorry, Kano. What time? "15 minutes. Great. Okay. So this is lane-shaped galaxies. Are the galaxies, they are separated by big distance only, or they are close by, or they just go along each other? What are they? Actually, they don't stay for a quite long time. They can be separated by long distance, but they might merge together, or they might interact with each other together. Those galaxies are known as interacting galaxies. So this galaxy named as antenna galaxy. So this is like basically two galaxies, they are merging into each other. How can I say that there is two galaxies, this is not a single galaxy? So if you carefully look at the lights, you will find two bright centers. The galaxy generally have one center. So if you find two centers, which means there are two separated galaxies was there, which are now they are interacting with each other. And this interaction process may take a longer time. This is going to change the shape, size of original galaxies. So there are lots of such kind of example. For example, you see all of them, this one, this one, this one, they are galaxies, two galaxies are merging with each other. They are interacting with each other. And our galaxy is going to merge with the Andromeda galaxy within few years. 2 years, 3 years, 4 billion years. So don't worry. This is the time scale. This is the time scale for any interaction happening in the universe. Billion years, million years, such kind of time scale. So don't worry about it. Okay? So this is the interacting galaxies. Now, as I mentioned already in the beginning, that we need to observe galaxies not only through optical telescope, but we need to see from other telescope. This is one of such image. This is a radio image. So the image has been taken with the help of radio telescope. Radio telescope are sensitive to the radio wavelength. What is the wavelength of radio light? Wavelength of radio light. Don't you listen to radios anymore? What, FM? Anyone, FM? Yes. What is that? Frequency. Whatever the FM says. Yes, 94.5. Yes. 100? What unit? Well, you are talking about frequencies, okay, fine, even not 10 to 100, even more. It's, if you think about in terms of wavelength, this is, say, centimeter, meter, even kilometer. Now, given the wavelength, you can convert it into the, anyway, he has tried, so give him one prize. Okay? All right. So, coming back to this image. So, this is a radio image combined with the optical image. If you have seen only through the optical telescope, you will see a bright spot here. But in the radio image, you see such a beautiful things. Two jets are coming out of it in two directions. And this is the central galaxy. So the jets are coming out much away from the galaxy. These are very energetic jets. This can be only seen through radio telescope. Okay? Are the galaxies only quiet? They don't do anything? No. There is vigorous amount of outflows. What do you mean by outflows? Sir, winds coming out of materials, gas, they are coming out of the galaxies. So this reddish things, it's a M82 image, it's a HST image, Hubble Space Telescope image. These things are coming out of this galaxy due to explosions of stars which are known as supernova explosions. Okay? Due to the energetic supernova explosion, it's like you are having a bomb which has exploded, and that is pushing out gas from the galaxy to the outside of the galaxy. So such kind of things also happens. Also, you see galaxies have magnetic fields. You can feel it. For example, our own Earth, we have magnetic fields. Anyone knows how much is the magnetic field of our Earth? The value of magnetic field of our Earth? No one? Okay. It's of the order of Gauss, 1 Gauss, half a Gauss. Actually, the unit Gauss came from the fact that we have Earth magnetic field is of the order of like this. But these magnetic fields in the galaxies, they are of the order of micro Gauss. Micro means 1 by 1 raised to 10 to the power 6. That is the micro Gauss. So the field value, the magnetic strength value here is pretty small, but it is there. Okay? The galaxies, they don't stay alone. They also form clusters. They stay together. Those are known as galaxy clusters. So actually, if you look at this image, apart from few cross-like structure, these crosses are stars. Apart from them, all the dots are individual galaxy. All the dots, whatever you find, shape, size, even the dots, they are individual galaxies. So it's believed that you can't count the total number of galaxies as such. It is believed that more than billions of galaxies are there in the total universe known to us. Okay? Right? This is kind of a survey of taking how far you can go in the past to see how many galaxies are there. This is known as 2DF Galaxy Redshift Survey. Each dot here is a galaxy. So you see they are some clustered, somewhere there is no galaxy, such kind of things happens. And from such kind of surveys, we get enormous information about galaxies, like how they distribute, how they evolve in time, how some other kind of things you can get it from such kind of observations. Then I said what are the high redshift galaxies. So redshift is a term that is used by the astronomer to say how distant they are. So high redshift galaxies mean they are distant galaxies. And distance means you know that light takes time to come from the object to us. Like from sun, light takes 8 minutes to come from her. So as you observe a distant galaxy, we are observing at a past So any distance galaxy is a past galaxy. Let's say Andromeda galaxy. That is not, we are seeing not how it looks like now. What it is looking like past a few million years ago. So that's why all the distance galaxies are very young galaxies. They are at the beginning of the universe. Those are high redshift galaxies. They look like a dot only. So they are so far away, if you take any image, they will look like a dot. Then how do you know they are a galaxy or not? We need to take their spectrum. The spectrum of stars are different from spectrum of galaxies. From the spectrum, we can find out what is the distance of that galaxy, and also we can find out what kind of galaxy it is. Okay? All right. So now again, why do you need 21 centimeter observation? As I said, 21 centimeter observation is going to give me the neutral hydrogen, amount of neutral hydrogen or existence of neutral hydrogen in any place. So this is a photograph. This photograph is an optical image, and this is a 21 centimeter image. Now compare. Well, first thing I can see, the optically the galaxy is pretty small. But if you look at it, H1, the neutral gas, is quite big. Okay? Which means gas are extended much more compared to the stars. So I can get information about the age of the galaxies from such kind of things. Also, one more advantage is that you see all the dots here which have been disappeared here. That is because it's a one wavelength measurement, and that can be restricted or decides also what is the distance of the galaxy. Depending on that, I can only measure or I can only photograph only these galaxies, not the background galaxies. This is another advantage of using 21 centimeter observation. Well, so the SKA is going to observe that, right? This 21 centimeter emission from galaxies, from young galaxies, from fast galaxies, and they are going to reveal how those fast galaxies look like, how their properties was, how they influence the evolution of the next generation of galaxies, and so on. Well, fine. So now you are excited about the SKA and you can join. Yes? 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 Great. Okay, thank you. So if you have any question, raise your hand. Yes.
So, when galaxies merge, then is there some modification in the contents of the galaxy?
Yes, not the total content, but when the merger happens, it produces more stars. That process is enhance the star formation rate of that galaxy. So the gas will convert to star. So gas will deplete and you will have more stars. Great. Any more? Yes. Actually, there is a, so distant galaxies, it has been observed that they are going away from us. distant galaxies. This produces something known as Doppler effect. Doppler effect is that whatever wavelength has been emitted, that's going to be stretched or elongated by that. So if I know the distance, I can find out what should be the 21 centimeter wavelength here for that particular galaxy, and I can only take that portion. That's why I can remove the other galaxies from there. Okay? Good question. Yes? Yeah, it could be anything. The shape, could be anything after the merger. And most likely, the elliptical galaxies are formed due to the merger of galaxies. Okay? Yes, you. Well, which class you are? 9. You know the linear momentum. That's the momentum due to linear motion. Angular momentum is the momentum due to the rotational motion. Okay? Yes, you. Yeah. How the number of stars? Calculated. So for our galaxy, you can actually count the numbers, and it's like, for example, how do I know the number of the students here? I will count here and average over here. So from the total light coming from a galaxy, I can find out what is the number of stars in that galaxy, because star light will be proportional to the number of stars. Okay? Yes. So between two galaxies, it's not completely empty. There are gas of hydrogen, helium and other gases, but amount is very, very small. The density of that gas is 1 atom per meter cube, whereas the density of our atmosphere, Avogadro number, correct? That is the density of atmosphere. So they are the very thin. It's 1 particle per meter cube. Yes. Move. They are moving with the help of gravity. They are moving with the help of gravity. So they are always in motion. They might interact with each other, they might rotate around each other, things are happening always. Well, I know there are lots of other questions. So what I will do, you listen to the next talk, and after the talk, if you still have you can ask me any question. Or you can, if you go to the Presidency website, the email address of mine is given there, you can email me, you can ask any question. Okay? Well, so enjoy the next talk.
Okay. Thank you, Soumyadip, for your excellent talks, and students particularly for actively participating in the talk. So before the next talk starts, I would like to ask 2 questions. What is the third most abundant element in the universe? What is the third most abundant element in the universe? Yes? No. Third? Yes? Lithium. Okay, so that's the correct answer. So he deserves a prize. Another question is, one very famous Indian scientist He was actually given Nobel Prize in Physics for his discovery, for his research on the evolution of stars. You know the name? Okay, so it's a Subramaniam Chandrasekhar.